Hi everyone, we're starting section 17D from the MYP 5 Plus textbook. We are continuing with quadratics and we're going to be looking at the axis of symmetry formula and the vertex and how they can be used in different situations. Okay, so up till now what we have seen is that every time we wanted to find the axis of symmetry we would have to change the any equation. Let's say we had x squared plus 8x minus 4, for example. So if we had an equation like this and we wanted to figure out what the axis of symmetry was or find out what the vertex was, what we ended up doing was we ended up completing the square. Okay, so we said, all right, we would have x squared plus 8x, and then it would be half of 8 is 4, and it would be plus 16 minus 4, and then it would be x plus 4 all squared minus 20. And then based on this, I could come to the conclusion, and say that my vertex was equal to negative 4, negative 20, and that my axis of symmetry equation was going to be x equaling negative 4. Okay, well what we're going to be introduced today to is a new formula or a new way of figuring out what the equation for the axis of symmetry is, and a new way to figure out our vertex without having to complete the square. So going from the ax squared plus bx plus c format and figuring out what our vertex is, hk, and our axis of symmetry equation without having to complete the square. We're going to use another method. And the method that we're going to use involves a new equation that's called the equation for the axis of symmetry. And that equation is in this red box here, and it's called x equals negative b over 2a, where x actually stands for the value of the x of the vertex, or our axis of symmetry, because they are the one and the same. Okay, or the axis of symmetry. Alright, so that we say x equals negative b over 2a. So now, every time that we've got a quadratic equation in the general form, it's no longer necessary for us to complete the square to figure out what the vertex is, unless we're specifically told to do so. Okay? So here's an example. If you're given that y is equal to 2x squared plus 6x minus 1, well, this is already in the standard form or in the general form. So we know that the value of a is equal to 2, we know the value of b is equal to 6, and the value of c is equal to negative 1. Now, if I use my formula x equals negative b over 2a, well, that becomes negative 6 divided by 2 times 2. And that gives us an answer of negative 6/4, which when reduced becomes negative 3/2. So that tells us that the axis of symmetry, so remember the axis of symmetry is that line that divides the parabola exactly into 2 halves, but it's also the x value of the vertex, is now found. We found it using another formula instead of completing the square. Now what we can do is, because we know what the x value is of the vertex, all we need to do is take that x value from the vertex and substitute it back inside the original equation of 2x squared plus 6x minus 1 to find the y value of the vertex. So we can figure out what our k value is in the hk. So the h is our axis of symmetry, or our x value, and the k is our y value of the vertex, which we know to be, we call it k. H being the x value of the vertex, k being the y value of the vertex, when we look at our equation in the vertex form. So all I do is I substitute negative 3/2 back into the original equation in order to find the corresponding y value when my x value equals negative 3/2. And therefore we know, once we've done that and worked it out, we get a negative 11/2. So I know at this point that the vertex of my parabola has negative 3/2 and negative 11 over 2 in it. So that's its lowest point, okay, because we know that our graph is facing upwards. All right, so if I have to figure out in this next question, determine the equation of the axis of symmetry. So again, I'm going to say x is equal to negative b divided by 2a, where I know that a is equal to 2, b is equal to negative 6, so that it will become negative 6 divided by 2 times 2, so that we have 6 over 4, which equals 3 over 2. So there we go. There's our equation for the axis of symmetry. The equation is just x equals 3 over 2. That's all the question is asking. It's not asking for the vertex. If it had asked for the vertex, then we would have taken the 3/2 for the x and replaced it back inside the equation to get the value of y, of the vertex. Okay, so if we were doing the next one, let's try another one that has decimal, a fraction in it. So what we have is we've got a equaling 1/2, b is equal to negative 10, and so we have x is equal to negative b divided by 2a. So we have negative 10 divided by 2 times 1/2, and that goes to 10 over 2 divided by 2 is just 1, which makes it just equal to 10. Therefore, our axis of symmetry formula is equal to 10. All right, let's take a look at the next question. Now it says, sketch the graph of the following by considering the value of a, the y-intercept, and the x-intercepts. Okay, so let's start looking at the value of a. Well, we know that the value of a is equal to 2. Our value of b is equal to 3. Our value of the c is equal to 2 as well. We may not need the value of c, however, but it is actually we do, because it's our y-intercept, if we all recall. Okay, so what we're going to do is we know that the value of a is equal to 2, so that's our vertical stretch. Okay, in part 2, the y-intercept, we know it to be the c value, so that the y-intercept in part 2 is going to equal 0, 2. So that's another piece of information that we have in the equation. And then in the third part of the equation, we have to consider the x-intercepts. So let's take a look at the possibilities for the x-intercepts. So for the x-intercepts, well, we are going to let y equal 0, so that's equal to 2x squared plus 3x plus 2. So I could try at this point to see if I can split the middle term. So I'm looking for two numbers that multiplied together will give me positive 4, but added together will give me 3. It's not going to work out because both of these numbers are positive, and there are no two numbers that multiplied that equal 4 and added equal 3. Therefore, I'm going to use the quadratic formula at this point. So I'll do negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so I can say that my value of a, so my value of b is 3. So it's negative 3 plus or minus, and it will be 3 squared. Let me just get this correct. It'll be 3 squared minus 4 times 2 times c, which is 2, and that's all divided by 2 times 2. And when I continue this, I get negative 3 plus or minus, and I have 9 minus 16, all divided by 4. And as soon as I see this, I start seeing that there's an issue. The issue being that I've got negative 3 plus or minus the square root of negative 7 all over 4. And because I cannot have a negative number under the square root, my only conclusion is that I have no x-intercepts. And if there's no x-intercepts, then it doesn't touch the x-axis. so that I can say very clearly, therefore, there are no x-intercepts. Okay, but since we know that there are no x-intercepts, we can, however, we are being asked to sketch the graph. So sketching the graph means that we need to find a vertex at least. So we can find the vertex by using the formula, x is equal to negative b over 2a, because this will give me the x value of the vertex, which is the axis of symmetry. Okay, so I say x is equal to negative 3 divided by 2 times 2, and that ends up giving me negative 3/4. So I know that the x value, of the vertex equals negative 3/4. So we take the value of the x of the vertex and we substitute it into the given equation. So substitute into y equals 2x squared plus 3x plus 2. And in the substitution of that, so we have y equals 2 times negative 3/4 squared plus 3 times negative 3/4 plus 2. We come up with our answer of 2 times 9 over 16 plus minus 9 over 4 plus 2, so that we end up with 9 over 8 minus 9 over 4 plus 2, and therefore getting a common denominator, it's 9 over 8 minus 18 over 8 and plus 16 over 8. And therefore we have 9 minus 2, which is 7 over 8. So we now know that the vertex is going to be at negative 3/4 and 7/8. Now if we're going to graph this, we have enough information to be able to graph, so that we know now that in graphing we have our y-intercept, and our y-intercept was found at 0, 2. So I know that 0, 2 is my y-intercept, and we also know that the vertex is found at negative 3/4, so it's approximately here, negative 3/4, and we know that the other point is found at negative 3/4 and 7/8, which is somewhere over here. Okay, so negative 3/4 and 7/8. So now we have enough information to graph the parabola, and what we need to just take a look at is make sure whether the parabola is facing upwards or downwards. Because it's positive, it's facing upwards, and therefore our graph is going to look as a sketch approximately as such. And there is our parabola for y equals 2x squared plus 3x plus 2. Okay, remembering always, of course, to label all axes and show the scale on the axes and the origin. Okay, let's move on to another question. Now, on to another question. One thing that you should be aware of is that the vertex could also be called something else. The vertex could also be called the turning point, because it's the highest or the lowest point of the parabola. So if we had to find the turning point or the vertex of the following equation, such as negative x squared minus 4x minus 9, again, we can always use the equation for the vertex, which is negative b over 2a. So it would be negative 4 all divided by 2 times negative 1, which gives us 4 over negative 2, which equals negative 2. Therefore, I know that the x value is equal to negative 2, and therefore I substitute x equals -2 into the given equation to find the corresponding y value. Okay, so I place then into the equation the value of -2, so that I have y is equal to (-2 squared minus 4 times -2 times -9, and then solving for that very quickly, I end up getting -4 plus 8 minus 9. -13 plus 8 gives me -5. Therefore, we know now that the vertex, or the turning point, is going to be -2 and -5. All right. All right, let's look at another question. It says, find all the x-intercepts of the quadratic function which cuts the x-axis at -1 and has an axis of symmetry that's at x equaling -1.5. Okay, so if our axis of symmetry is found at -1.5, okay, -1.5, and we know that one of the x-intercepts, if it cuts the x-axis at -1, it cuts it right here, that means that the other point, or the other x value of the other x-intercept is going to have to be half a point away, because if this is found at 1 and this one's at -1 and this is at -1.5, it means that the next one, or the other x-intercept, is going to have to be found at x equaling -2. Therefore, all the x-intercepts then are going to be, the first one is given, so the x-intercept is at -1, one of them, and the other x-intercept, based on the axis of symmetry, which is at 1.5, means that the other one must be found at -2, because it's a distance of 1.5 away, and that's basically what we're looking at here. Okay, so the distance from here to here and here to here has to be the same. Okay. All right, so I have here a couple of explanations just on the review of Chapter 17 so far. The last thing that we're going to be looking at in the chapter is we're going to just be looking at how to use real-world models or real-life situations with parabolas in order to solve questions such as looking at maximum profits, or looking at minimum losses, and so forth. Okay, so we have then in the review of Chapter 17. This is quite a nice review of everything that we've done in Chapter 17 so far. So we've had the standard form, or the general form, is equal to ax squared plus bx plus c, and the concavity of the graph, or concavity of the graph, is determined by the sign of A. So if it's looking upwards, if the opening is upwards, it's concave up. If it's negative, the graph, then it's concave down. And the y-intercept is always going to be the value of the c, so it'll be 0 and c. Now, if we take the standard form and we factorize it, we get the value, we get the formula y equals a bracket x minus p times x minus q, which we know to be the intercept form here. Okay, so the intercept form gives us what the x-intercepts are, and we can figure out what our axis of symmetry is by taking our x-intercepts, p and q, adding them, so it's right here, adding them and dividing them by 2. And again, the direction of the parabola, whether it's facing up or whether it's facing down, is going to depend on whether the value of a is greater than 0 or less than 0. Now, they give you a whole bunch of information here. The y-intercept is given by a times p times q. That's not necessary for you to know. Just let x equal 0, or let y equal 0, let x equal 0 to find the y-intercept. So all I have to do, as far as we know, that when we want to figure out what the y-intercept is in the factorized form or in the intercept form, all we need to do is let x equal 0 to find our corresponding value of y, or our y-intercept. Then the third method that we learned was the vertex or the turning point form, which was y equals a bracket x minus h all squared plus k. And the coordinates of the graph, hk, is the vertex, where the value of the h corresponds to the axis of symmetry, which divides the graph up into two identical parts, so it divides the graph in half. Okay? And we know that we can now figure out the axis of symmetry without having to use, without having to figure out the vertex form from the standard form, or from the general form by completing the square. We can now figure out what the vertex is in a much faster and simpler way by using the formula x or h. Doesn't matter whether it's x or h, it's referring to the x value of the vertex, which is equal to negative b all divided by 2a. And the y-intercept, well, we can always figure that out by letting x equal 0 in the original equation. And so again, the y-intercept, they give you this equation by a times h squared plus k. You don't need to understand that. You don't need to have that memorized. All we want to do is, when we want to find the y-intercept, we let x equal 0 and then solve for y. Okay, so your work will be basically to complete exercise 17D. And these are the questions that you'll be doing for me for the next class. All right, see you then. See you next time.